We'll have a lot of Python examples just to show you how you can access the C# or .NET features from Python. But I'm just letting you know, and if you have any concerns or questions, let me know afterwards, and I'll try and address that. I was very vague in what I said, but it's about half and half. So there's Python script examples that access the CLR features, but the two big examples for integrating Python into the CLR are C# projects. I'll get to that. All right, so for those who didn't hear, I'll summarize this question. Is Microsoft for real or are they for fake? And I'd say they're for real right now. They are definitely extending their hand into the open source community. They've open sourced the core CLR and that the whole .NET framework, the entire standard library, stuff like that. That's really showing good things for us .NET developers. But they're also doing a lot of Python, and they have a Python blog in which they put up some interesting posts, some beginner level posts about the stuff that they're doing. So we know that Microsoft's doing Python. We know they're interested. We know that they own Python tools for Visual Studio. I believe Microsoft has annexed that project, and it's an official Microsoft project now. So there's definite interest from Microsoft in the open source community. They're definitely putting their hand out there a little bit. Um, Let me put it this way. 2 years ago, my best friend, who's a big-time Python developer, it's where really I got my love of Python. I got it from him. He can make fun of me for Microsoft and .NET, and now I can make fun of him because now he's wrong. So it's come a long way, I think. Yeah, this talk is probably, I'd say, intermediate experience level because it doesn't go deep into Python features and it doesn't really go deep into .NET features. It just something that's possible, I guess. Right. And I'll try and cover things from just the beginner's perspective, something that everybody can understand. I don't really want to go too deep into the features, and if I do, it'll be a quick touch on fun facts type of thing. Now I really will be narrating off my slide. Um, yeah, that is. Okay, I think tiny box is better than full slide, so we're gonna have to get that back, and then I'll get started. I will introduce myself though, so we can at least get something going. That's just a slide you'll have to miss. Hi, I'm Hussein Farran. I'm a software developer at United Shore. We're a wholesale mortgage lending company over in Troy, Michigan. So if you need a mortgage, go to shoremortgage.com and I don't know, talk to somebody. I don't know how that works. But I started professionally doing software about 2 years ago, maybe almost 2.5. I started off in a boot camp program in downtown Detroit called Grand Circus. And, well, it was in Grand Circus. They called it Experience IT. And what that was is just a boot camp where you get interviews with companies in the local area. And I started off with Use Tech Design, who hired me on. After about a year and a half, I moved on to United Shore. So mostly I've done .NET throughout my life. I do C# professionally. But Python has been a big part of my life. It's probably the first programming language I really learned and really got the hang of and learned programming through. So it's really close to me. I really like it, and that's why I always give Python talks, even though I'm a .NET developer. And everybody who asks me what I'm talking about at work just goes, "What's that?" So I want to talk about IronPython and what this talk is not, which is IronPython. This is not IronPython. Um, so let me tell you the difference. This talk is going to be about a project called Python for .NET. And Python for .NET is it's a wrapper around the C-level APIs of Python. So Python for .NET just runs C Python. And it's just .NET code that wraps the C API. So we're just using .NET to call into C Python and run code through that. IronPython is a re-implementation of Python. It is an entirely different interpreter started by some dudes, bought up by Microsoft. I think it's actually coming back. There's been some talk. But it is a Python interpreter written in C#. It is a completely different way of implementing Python than Python for .NET. The differences, one of the key differences I want to note, is that IronPython does not support C extensions. I think they're working on that. They had a branch going on that, but since IronPython fell off the face of the earth, that's definitely not working at the moment. But here's the pros of it. IronPython is not locked down by the global interpreter lock. So threading can be truly multi-threaded because it uses the .NET Frameworks threads. So Python for .NET is the C-level API being wrapped, which means it is locked down by the global interpreter lock. What that means is that threads never truly operate simultaneously. They are actually working sequentially, kind of locked down to one thread running at the same time or at one time. So the catch there is you can use C extensions with Python for .NET. So you can load up C extensions and use them and access their fields inside of your .NET application from the Python world. So there are pros and cons to both implementations, but I'm going to be covering Python for .NET. So I want to show you some code. Well, I want to show them some code. That's what I was afraid of. This is pretty easy, though. Everybody can get that, right? For everybody moving around, it's a script. One line says print foobar. It's a Python script. It's nothing special. Get out of the way. So I'm going to compile this Python script into a DLL using IronPython. And I get this decompiled. This is a decompiled .NET assembly. It's about 6 lines. And it looks like it loads up a data DLL and runs its entry point. And so I go into the data DLL and decompile that, and I get blah. This kind of highlights the difference. It's decompiled C# code. It's just highlighting the difference between Python for .NET and IronPython. IronPython generates common intermediate language, which is what C# compiles down to as an intermediate language. And it does that out of Python source code. It's a completely different interpreter. And the blah just keeps going. It IronPython tries to match Python's behavior and the spec, which means it's a lot of code, a lot of boilerplate just to get Python meta internals and meta programming and all that stuff going on. But Python for .NET is different. It only wraps the C API. When you run Python code, the .NET application is sending it down to the C-level API. It says, hey, C Python engine written by the Python Software Foundation. I'm not worried about it. Just do it. I'm not trying to re-implement anything here. I just want you to run it for me. So how do you install Python for .NET? Real easy. You go into pip. You do pip install pythonnet, and then you import CLR. And just like that, the whole .NET world is at your fingertips. From that, you can access the CLR module and import namespaces from the .NET world. And you can do that very easily just by importing them like you would modules in Python. So import the CLR module, and then you can import a namespace. So this code example shows me importing the point class from the system.drawing namespace. And it literally just says, from system.drawing, import point. Now I want to reemphasize, this is a .NET class. Yeah, it's a .NET class. You can also add references to your, I want to say, scope. You can add C# references. These are separate DLLs that aren't available in the standard library. So example, WinForms, Windows Forms, that you might see a lot of C# applications written, desktop applications. It's a GUI system for .NET, but it's not part of the standard library. You do have to load up the separate DLL and add it as a reference to your project. But over here, I'm doing that through the function available from the CLR module. I do CLR.addReference. Then I give it a string, which is the name of my reference. In this case, it's just a string that says system.windows.forms. And then I can import the namespace doing import system.windows.forms. So let's not do anything.
So I took the input from this and sent it that way.
Okay. All right.
I'm with you on that.
I'm going to stand over somewhere not in the way. Wonderful. Okay, I have my laptop to look at. Can everybody see that just fine? Wonderful. Sorry about the technical difficulties. I know that's the cliche, technical difficulties, but we'll just put up with it. If anybody would like me to go back over something we've covered that you may have missed, come up after the talk, and I will happily cover that stuff and go through it again. But for now, we're just going to move on because now we're time constrained. So C# classes can be accessed through, or .NET classes can be accessed through Python through the CLR module. After you've imported them, you can simply instantiate them like any other class. In this example, I'm doing some file writing using the .NET facilities instead of the Python facilities. So I have imported CLR, because you must import CLR to access the .NET framework, and I've imported file from system.io, and I've imported encoding from system.text. And I'm going to file.writeAllText. So file is a static class. Its fields are available outside of a instantiated scope. And I can do writeAllText to the file. Check out my overloads. So in C#, you have overloads to your methods. This is something that's common in object-oriented principles. And Python is just sort of starting to get that with multiple dispatch, but I won't get into that. But you can access specific overloads of C# types as its index arguments, and then it will return the proper overload. If you put in, obviously, types for which there was no overload, then you'll get an exception. So I know there's a writeAllText that takes a string, and an encoding. Those two strings are the file name and file content, and the encoding is the encoding that I want to encode it in. I want to rewrite all that text to faz.text, and I'm going to write baz to that, and I'm going to encode it in UTF-8. By the way, .NET's default encoding is UTF-16. So I am doing something different here. I'm not just doing nothing. So notice that I assigned the overload, the result of the overload, to a variable. This is Python. Everything's first class. It's perfectly fine to do that, even though it's a .NET method. We can also use .NET generics. So in .NET, because we have a compiler and we're statically typed and we're trying to be as type safe as possible, our list class doesn't just take anything. That's something that I missed from Python, but we have to instantiate lists that contain a certain type. In this case, our generic, we import everything from the system.collections.generic namespace. This is where our collections exist in the .NET framework. And we have the list class, which is taking in a type argument, or in this case, an index argument in Python, of string. So I've saved the results of this indexing to string list, the variable. And when I instantiate string list, I know I have a list of strings from the .NET framework, which I can add strings to. Python for .NET automatically marshals over Python strings to .NET strings, as well as all the numbers. So it'll automatically try and fit all the numbers into the proper .NET data types, because we have separate data types for different sizes of numbers. The strings are automatically moved over, despite the fact that Python has some different strings. So that stuff is kind of handled automatically. Do you have a question? How does Python for .NET handle decimals? I believe it will take Python numbers, which are decimals, and try to convert them over to .NET Framework decimal class. That is what I think off the top of my head. But if you're really curious, we can check it out after the talk, because I'm not 100% sure. So moving on. Moving on. Fields, properties, indexers. I'm just going to gloss over this because it's exactly what you expect it to be. You access .NET fields, you access .NET indexers, you access .NET properties, just like you would any Python field or any Python property. It all works the exact same way that you know about .NET. It's all just working. It's just normal. How you expect to use code is how it is. Trust me, .NET stuff isn't some foreign thing that's scary. You can iterate through collections. You can iterate through .NET collections using the for loop in Python. So in .NET, we have an interface we call IEnumerable. And if your class implements IEnumerable, you're able to iterate through your class using your for each loop. In Python, or in .NET, we have a for each loop, or in C#. In Python, we have a for loop that is functionally equivalent. And Python for .NET knows how to generate iterators for these IEnumerable classes. So you can access a .NET IEnumerable from Python and iterate through it just like you would with a normal for loop. So in this case, we have the app domain static class from the system namespace. We're doing app domain.current.domain.get assemblies. This is just all the local references and DLLs loaded in the current scope. And we're just iterating through them, printing them off, because this is the quickest list that I can find statically. Another question? Can you use Python lambda expressions for what? Not sure what you mean by that. I'll get with you afterwards and I'll answer that question. Delegates. So in .NET, for those not familiar, because this is going to be a foreign concept for those who just do Python, in .NET we don't have first-class functions. Not really. What that means is we can't just assign functions to variables and throw them around. .NET is pretty difficult, or not .NET, but C# is pretty difficult to do functional programming in. F# kind of solves that problem, which is our functional programming language for the .NET framework. But in C# we have delegates, which we can use to define a kind of like a function pointer, almost, not really. And we can assign functions to that and pass that around. In the case of Python, this kind of clashes. We can't have this clashing with Python and the .NET framework. So Python for .NET tries to automatically resolve Python functions into delegates for the .NET framework to use. And we already know that it resolves .NET framework methods into functions for Python to use. So in our case, we have a delegate, which is defined in the system namespace. It's called assembly load event handler. And we're going to instantiate that delegate with a Python function that takes the same arguments, or as the same type signature. Well, in Python, we aren't statically typed. We don't know if it's the same type signature, but it does have the same number of arguments, so that's good enough. We don't care what the types are in Python. We're not doing any static analysis. So this assignment of the delegate, or instantiating this delegate, works with our load event handler function, our Python function, because it takes in the same arguments, and really that's all we can go on the .NET side. But that brings us to events. Events are a feature of C#, and I believe the .NET framework are cooked in there as well. Basically, it is you can register a delegate to an event, and when that event occurs, your delegate will automatically be run. You don't have to manually do any of that checking. Event runs, your delegate runs, And our assignment for delegates to events is using this plus equals overload. So from the top to bottom, we have a button from WinForms. And this is just the GUI system that we talked about that the C# has. And we have a delegate, or a function that we're going to use as a delegate called clickHandler. And it takes in a source argument and an arg argument. And these are the same number of arguments that the required delegate for the event handler has. And we just print off something like I got clicked or whatever, because this is a button. And we're going to go button.mouseClick. This is our event. This is something defined in the .NET framework. And we're going to do plus equals so that we assign our delegate to the mouse click. So we plus equals clickHandler. And now when the button is clicked by the mouse, just the left mouse click, we'll get a printed off statement, I got clicked. So events work, for those of you familiar with the .NET framework, and those of you familiar with C#, they work exactly like they worked in C#. You just plus equals. I think you can even minus equals to unregister an event. It all works like that. For those of you in Python, I don't believe Python has a built like a language syntax for this. This is just the way that we handle some of that event-based programming. So how do you embed your Python into your C# code? How do you make your .NET framework application run Python code in a reasonable manner? You can do a few things. You could just run code strings through the Python engine. You can import modules to the engine, or you can just point the engine to a file and say run that. So we're going to go over an example of how I do that. I'm going to build a REPL in C# using Python for .NET to run Python code and print off the results. So a REPL is a read, evaluate, print loop. What that means is that if you've ever seen your Python console where you launch it up and you type stuff in and it's code and it prints off the results of that code, that's a REPL. We're just trying to replicate that functionality to some basic extent. We're not writing IPython here. We're just doing something simple to demonstrate how you can script here. So this is C# code. I started up a C# project. This is a console application. For those of you who aren't C# developers, we're going to walk through it, and hopefully the code is easy enough to understand. I'm sorry about the braces, those weird things, but hopefully we'll survive. So first thing I do at the start of my application is I do Python engine.initialize. I've already imported added the reference and imported the namespace for the pythonnet DLL. I don't remember what the DLL is called off the top of my head, but we'll survive. And then I just do a quick while loop. I just, what's the word? Infinite loop, undefined, I don't remember, indefinite loop of write off a prompt, console.write, 3 angle brackets like we would see in the Python prompt for our Python console. And then we do a quick read line to gather anything that somebody typed in, which could be code. And if they happen to type in exit as a function, we just get out of there. I'm not going to actually put in the exit function into our scope because it's just easier to detect if they typed it. Now we're going to move on and create another function within our application. It's going to call create globals. So the thing about the Python C API is you can do one of two things. You can initialize the Python engine the same way that they do when they initialize their REPL. So when you launch the Python console, it initializes all the scope, initializes pretty much all your globals, all the locals are made for you. That's a lot of stuff, and Python relies on some of that stuff for its functionality. But we're just going to cheat and provide it a globals dictionary. In our C# code, we're going to initialize a new pydict. This acts as a Python dictionary from our C# side, and we can pass that into Python for them to handle it. Thank you. So we're going to set random to Python engine.import module random. So assuming that the Python engine can find the random module, which if you just have a Python installation on your system, it will. We're just going to add that one module to our